All right, so let's start with the graph, e to the negative x, and then y equal x plus 1 is going to look like this. X equal 2 is going to be here. All right, so this is the area bounded. I'm going to be revolving it about x equal 3, which is over here. Okay, so I get to choose how I want to build the rectangles. I think if I drew them sideways, perpendicular to the axis of rotation, I would get a different bottom function. So let's not do that. Let's draw the rectangles parallel so that I can see that my shell goes all the way over here. So 2 pi radius height dx integration. Okay, so my radius will be from here to here. So everything gets measured here from the y-axis. So I want to say go all the way out to 3 and take away this x. Go all the way out to 3 and take away x, and that gives me the radius of my shell. The height of the shell will be this distance from here to here. So the top function is x plus 1. Oops, sorry about that. Let's see, x plus 1. And the bottom function is the e to the negative x. And where on the x-axis am I building rectangles from and to? From x equals 0 to x equal 2. All right. Let's do e to the negative x, which looks like this. E to the x crosses here, and x equal 2 is here. So this is the area contained, and I'm revolving it about x equal 4. X equal 4. So again, I'm going to want to draw parallel to the axis of rotation. So my volume will be 2 pi radius height dx. Okay, so let's look at this radius. It's a little challenging. So radius is this distance right here. So everything gets measured here from the y-axis. So I want to say go all the way out to 4 and take away this distance of x, and that gives me the leftover, what the radius is inside, 4 minus x. The height of the rectangle will be from top minus bottom. So it looks like the top function is e to the x, and the bottom function is e to the negative x that I'm subtracting off. And I'm going to be building rectangles from 0 to 2. All right, y equal x looks like this. Then y equal 2 minus x looks like this. And y equals 0 is this. All right, so this is the area bounded. And I'm revolving it around y equal negative 1. All right, so y equal negative 1 is down here. Okay, so I'm going to draw rectangles parallel to the axis of rotation, so they always have the same top and bottom function. If I drew them the other way, I would have different top functions. That would make more work for me. I don't want to do that. So here, okay, so let's find our volume. I can see it's going to be a shell, so it's 2 pi radius height, and I see that the thickness of my rectangle is dy. All right, so the radius is a little more challenging. So the radius is this distance here. So from here to here is a distance of 1, and then from here to here is a distance of y. So radius always has to be a positive quantity, so I want to say the distance of y add on 1. Then the height will be from here to here. So taking this and solving it for x, that'll be 2 minus y, so that's the top function. And the bottom function will be subtract y. And I'm going to be building the rectangles from 0 to where they intersect up here. And that is going to be at 2. because x is equal to 2 minus x. Pull this over, 2x is 2. I'm sorry, so x equals 1. Well, x equal 1. I'm sorry, y equal 1. Oops, x equal 1, which gives us y equal 1. Yes, sorry about that. So I get x equal 1, and then I put that back into y equal x, and that gives me the y value of 1. All right, y equal x to the 1/3. It looks like this. 1 over x. And then I'm just going to do this part because I see that I'm also going to be talking about x equal 2. So it's going to be this part of the graph over here that I'm looking at. And I'm revolving it about x equal -2, which is back here. All right. So I'm going to draw the rectangles parallel to the axis of rotation. So my volume will be 2 pi. Radius, height, I can see it's going to be dx integration. So this is the y-axis right here, and this is the center that I'm spinning it around. So the radius, which is from here to the y-axis, all the way out to here. So this distance from here to here is a distance of 2, and this distance here to here where I'm building the rectangle, that's a distance of x. So it's going to be 2 plus x for the radius. Then the height of the rectangle will be the top function, which is x to the 1/3. Subtract off the bottom function, which is 1 over x. And I'm going to begin building the rectangles here at x equal 1 and finish at x equal 2. Let's just finish off with this last one. So it's the same area, I'm just revolving it about y equal 2. So let's get this graph going again. So x equal 2, y equal 1 over x. So it looks like that. Okay, so now I'm revolving it about y equal 2, which is up here. So this is the center. So this time I don't want to draw parallel, because if I draw parallel, I've got different bottom functions for my rectangles. So I want to draw perpendicular to the axis of rotation. So it's going to be dx integration, and I see I've got a washer. So the outside radius, remember how you find the radius, right? So the outside radius is from here out to here. So to get that distance as the outside radius, I'm going to say go all the way up to 2 and take away this function, which is 1 over x. Then to get the inside radius, which is this distance here, I want to say go all the way out to 2 and take away this function, which is x to the 1/3. And then I want to start building them where they meet, which is 1, and end building them at 2.